record. Okay, yeah. So like I said, one of the most important things in to build a platformer that you should start from is your player movement, right? So in Unity, there's different types of movement that you can use, like different components in Unity that you can use to move the character. Some of you might have some experience with this, like for example, using transform or add force, or even rigid body 2D. And today's workshop will actually be covering movement using rigid body 2D because it's much easier to implement, and basically using rigid body allows you to have very smooth looking movements. So by the end of the workshop, you should like have the ability to get something like this. It's just a jumping square that can move left and right. Yeah. So let's begin the Unity tutorial. Before that, does anyone have any problems with Unity at all? Like, okay. I have my helpful Exco members in the chat. If you have any questions. So if you have any questions at any time, just do put it in the chat. And if you want me to slow down at any point, just put it in the chat also. Yeah. All right, so let's begin. So from the survey on Discord, majority of you are probably like beginners and want to start learning how to do stuff in Unity from scratch. So just a quick refresher. Unity as a game engine uses a component system. So everything in this game engine derives from an empty game object, which is this. So this empty game object has just one thing, which is the transform of a component. And it's just this for now. So what we want to do is now I want to create a player character. So to do that, the simple one would be 2D object. I right click over here in the hierarchy, 2D object, sprites, and square over here. And you just click. And you should be able to see a like cute little square in the center of your screen over here. When you left click the square, you let's assign a color to the square. So for simplicity's sake, I'm gonna go with red. If you don't like red, you can go green. You can go like really nice, like whatever color you want. But for this workshop, I'm just gonna go with red for player. And what you also want is what you also want is you may want to have another square. So what you can do is 2D object, sprite square. And for this one, maybe I want to scale it a bit far. So like, let's say 10. So this can give like the, is someone saying something or, okay. So let's say I want to scale this by 10 and this will act as the platform that the player can walk on. Okay, let's change this to black because it's a very stark contrast between the player as well as the black platform. So for now, let's just hop into the scene and see what it looks like. So right now it doesn't, you can't even see it on the screen because the main camera over here is gizmos on. Yeah, so as you can see, this is where the main camera thing is. The camera basically captures everything in the scene. And right now, all our objects is outside the scene. So if that's the case, all you have to do is drag it into the scene. And then if you click camera again, it should appear here. So if I click play, and it should appear. Yeah, but right now, the two of these objects just stay still and they're not really doing anything because we haven't really applied any like gravity, any different components to it. Yeah, okay. So right now, let's, for simplicity's sake and for clarity's sake, let's rename this to player as well as platform. So we can have a clear distinction on which is which. Okay, so moving on to how you design a player in a game. Right now, what some of the main components you want to put in is a collider component. So what colliders do is they basically handle all the collisions with other colliders, as the name suggests. So right now, you over here, or in case you also missed it, it's add component. You click on the player and you add component and you search box collider 2D, which is this component right here. And all you have to do is click on it and it automatically adds it to the game object. So right now we have a box collider 2D for the player. And let's do the same thing for the platform. So the platform should also have a collider, the same thing, box collider 2D. And you can see there's a green outline. If you want to edit what the collider should look like, you can click on this button right here, and then you can like drag how big you want the collider to be. But for now, let's stick it to the shape. Next, what you're going to want to do is add another component, which is your rigid body 2D component. This allows your body to have actual mass. So as you can see, there are many parameters over here, like mass, angular drag, linear drag. These are all how Unity simulates air resistance in game, as well as gravity scale. So it's how large the gravity is or in your game itself. So let's click play just to show you what happens. Yeah, right now it falls and it lands on the platform, but you can press the arrow keys right now and it doesn't really do anything. That's because we haven't coded anything for this specific player yet. So what are we gonna do? Well, now we have to look into a bit of code. But before I continue, is there anyone that like wants me to slow down? Am I going too fast or? Okay. If I am going too fast, just let me know. Okay. So now let's go into our any folder you want. Right now I have it under scripts, and just create a new C# script, and then you can name it like player movement over here. So right now I'm just, since I have like the whole complete thing, I just named mine new player movement. So after you create it, go ahead and open it, and you should open it in your favorite text editor. I use VS Code, and you should install IntelliSense, unlike CG, who hates IntelliSense for some reason.
No, I do not hate it. My VSC just refuses to use it. Like I don't know why. I don't know what's wrong with my VSC, but whenever I open it or close it, there's some error. I'm quite sure it's related to that.
Yep. So remember to install IntelliSense, guys. If you don't know what it is, over down here we have extensions, and over here we have a whole bunch of stuff. But the one that you need is debugger for Unity as well as Unity tools. Honestly, when you first click on the script on Unity, you should automatically they should automatically install this if I'm not wrong. If not, then you can install it yourself. Yep. Okay, so let's start. Okay, I'm gonna give a brief rundown on all the functions that we are gonna be using. So let's start off with the first function on the top over here. So I'm just gonna delete this. So let's start off with a start function. Now, what this start function is that when the scene gets loaded, essentially when you press the play button, everything in this start function will get called. So let's start off quite simple. Let's make references to the components on your game object. So in this player game object, what you have is you have a rigid body component. So it's a rigid body 2D. I like to call my rigid bodies RB, but you can use like rigid body, whatever you want, whatever name you can give it, as long as it makes sense. And for this, I like to give collider. Okay, so I have a rigid body 2D as a component, as well as a box collider 2D as a component over here. Now, how do I link and initialize this is in my start function, I'm going to get component rigid body 2D for my rigid body. And I will do the same thing for the collider. So what I just did was I linked up this variable 2D variable in the, okay, let me just wait for it to load. Okay, I basically linked it up to these. And remember to add your script 2D to the player object. So mine is called new player movement, but yours should be called player movement or whatever you want to call it. And okay, let's go back to the script. So next, what you should want to do is this function. So what update does is this will run whatever code you write in here, it will run every, it's something quite, it's really very fast. It's like what, 300 times a second, that kind of thing. It'll basically run like every tick. So what you want to write here is a way to register your player input. So for example, let's say if I want to press left or right key, right? So right now, I can, okay, let's abstract this a bit. So I have a get movement inputs function that I can write over here. And what this function does is it will get the movement inputs of what I input inside my keyboard. So what you're going to want to do is you can input dot get axis raw axis. Okay, so input get axis horizontal. And this will essentially get a number between -1 and 1, depending if you press your A or D key or left and right key. Just for a demonstration, I shall print this out for you to see. So right now, okay, so in the console over here, you can see it prints 0, 0 because I'm not pressing key. Let's say I start pressing the left key. You can see it goes very fast and then goes to 1. Similarly, if I press the right key, it goes 0 to 1 and back again when I release it. If I press both of them at the same time, it should be very close to 0. Yeah, it should be close to 0. Yeah, it's basically 0 because 2 of them cancel out. And it also works with A and B keys. Yeah. So that's done. Oh, okay. Yeah. Underscore RV. Yes, if you wanna if you wanna standardize it. So over here, now there are two ways to actually do this. Perhaps a simpler way is to give this number like a put it as a parameter. So let's put a private float x-axis, and let's make x-axis equal to the number over on your left and right keys. Okay, so if you have the amount that you press on your keys into the game, what you can do is control the velocity of the rigid body. Now, what this means is that the rigid body will move in a vector equal to whatever you set this here. So RB.velocity actually takes in a vector 2, which means a 2D vector. And I want it to go on the x-axis. And you have to ask yourself, do you want your horizontal velocity to be affected by your vertical velocity? So clearly the answer is no, because you don't want like something messy to happen unless your game is something like that. So you're going to want to have your rb.velocity.y inside here. So what this does is it doesn't touch the y velocity at all, but you touch your x-axis. But right now, it will only go from the value from -1 to 1. So what you're going to want to do is add in another variable. Let's call this walk speed. So, and if you save and load it here, and okay, so this you multiply by walk speed. And what this does is it will multiply whether it's 1 or -1 to the walk speed. So in this case, if it's negative, your player will go towards the left. If it's positive, you go towards the right. And let's look at how it should look in Unity. So right now, this is the project. Let me just maximize on play. And for the player, you're going to want to adjust the walk speed over here to something like, let's just do 5 for now. And save and play.
Kenneth, could you go back to your code? Because I think you flash it pretty fast.
Sorry.
Some time for people to copy. Yeah. So
all right.
maybe just wait like 1 minute for people to just copy this code.
Yeah, sure. Sorry. Thank you.
So like this is quite interesting. You can actually adjust the input dot get axis horizontal. The x-axis speed, you can adjust it with your own private variable walk speed to give you some form of control on how fast your that player or your square is moving. Yeah. So I think that we just pause here for a while. Maybe if you have any questions on the code, please feel free to ask Kenneth. I mean, I can answer as well, but Kenneth is heading this session, so feel free to ask him.
I also pasted it in the chat in case you're lazy to type. Yeah. So as a reminder, all we're doing is this function is calling every tick. It will get the number from -1 to 1, depending on whether you press the left or right keys or the A or D keys. And you're putting it into a variable over here, which is adjusting, which is multiplying by the walk speed of the player that you set. And you're basically setting your rigid body's velocity to the new velocity you see over here. Yeah. I'll wait until like 8:01.
Yeah, so kind of like how I did for the other workshop was like, if people are following the code, then when they are done, they like put a thumbs up
like
or
a thumbs
something.
up. Okay,
yeah,
sure.
then they might be able to gauge the speed from there.
Okay, sure. I guess if you're done, you can put a thumbs up in the reaction, so you can let me know. Like, yeah, you can just do like a tick if you're done. Or more importantly, if you want to look at it more, you can put a cross. Yeah.
Okay, don't worry, Leon. You say you miss making the components. I think you just create this script first. Then maybe Kenneth later could just go through like the rigid body on the square and the box collider. Do you have the box collider?
Yeah, box collider 2D.
Yeah, so
can go through it later.
All this later we will go through again, but now you just copy this code first. Yeah, so that you can follow the rest later. Yeah. So just to summarize, this code is really just taking in like your left and right keys, the horizontal axis keys, and then making sure that like you make a certain form of velocity into the rigid body, okay, so that you actually move whatever object this rigid body is on. So you can treat this rigid body as something like a way to add force to an object. Like, you know, when you have a gravity or you have some world with physics forces, you need some form of actor to receive these forces. So this rigid body is the way that Unity like gets all these physics interactions done. Yeah, so you need this rigid body component in order to move your object. I mean, this is one way of moving. Other ways are just to do this transform dot position. Yeah, you can update the position of the object directly. But you know, it's more cool if you can update the physics. Yeah. All right, so back to you, Kenneth.
Yeah, thank you, Chomin. Julian asked in the chat, why does RB and Collider have an underscore in his name? It's just my own convention. I'm trying to write better code. So basically, if it's a class variable, I try to put like an underscore to identify that it's a class variable. Yeah. Yeah, you can write whatever you want. You can call it like rigid body 2D. You can call it like collider 2D. As long as you get what it is. Yeah. All right. I guess I will move on now. Okay. Let's go back to Unity and see how it looks like. Press play. And right now it falls. And if I move left and right, the guy moves left and right. Yay! So basically half your movement is essentially done, just like that. Yay! In 15 minutes. So what's missing in your game now is probably, as you may guess it, jumping, because it's a 2D side scroller kind of game. So let's implement jumping. There are a lot of ways to implement jumping. I think Chomin's way, like for example, Chomin will do it by seeing which layers are touching. So I'm going to do it a bit differently. Right now, I am going to use raycast. And why I use raycast is because in the future, if you do get very, very into, if you want to make a good platformer in the future, you will use these similar raycasts to raycast on slopes in order to determine the angle between the slope as well as the player to slow the player down or speed the player up using trigonometry. So I'm gonna use raycast right now. So in case you want to work on it on that in the future, you know, it's like a shortcut. So let's start doing that. So what I want now is a jump function. So I'm gonna try void jump. And all this, and I will call this every tick. So over here, I will call the jump function.
Sorry, Kenneth. Before we move on, could you just go through the components again? I mean, because someone just now asked for the rigid. Yeah, maybe just
Okay,
go through that.
sure.
Yeah, so that make sure people can move left and right first before we do the jump.
Okay. So just now, basically how I created the player and the platform is I right click to the object, sprites, and square. So this will create a white square in the middle of the screen. You can name it the player. I'm just going to call it player new. This is a new object. And over here, I'm going to add a component to it. So the two components you have to add for the player is the rigid body 2D component. So you search rigid body 2D. And it automatically just pops up here, as well as the box collider 2D. So you search box collider 2D, and it will be here. So as you can see, it has a box collider around it. And it also has a rigid body 2D component. Next, you also have to add the movement script that you created just now into the object. So right now, your player should look something like this, and you should change your walk speed to however fast you want the player to be. So in this case, I'm using a walk speed of 5. And for the platform, it's essentially the same thing. So you right click sprite square. And this time, you don't want it to have a rigid component, a rigid body component. Excuse me. So you only have a box collider 2D component. And what I did was I edited the color of it to black. So if you click on this color over here, you can drag it over here to make it black. And then you can scale it however you want, like 50, make it a really long platform, or like 2 if you make it a rather short platform. But for this, I made it scale by 10 by 1. So yeah, that's how you add these components. Yeah. I hope you all managed to catch up to that. If anyone has any problems and your character is not moving left and right, please let us know in the Zoom chat so my helpers can help you out. Yeah. Yeah, VSC, you can install Visual Studio Code. Yeah, the glorified text editor. Yeah. So if anyone has problems in the chat, please notify the helpers. And if not, I shall move a bit slower in case someone didn't catch it. So now I'm gonna start on the jump. And for the jump, what I'm gonna do is I'm going to get an input for the jump. So I'm gonna write if input dot get key down, and I want the key code of space. So you can write it as in, like, for example, if you want to jump using X for some reason, you can write key code dot X, and if you type in key code X, then it will basically equal to true. So when I type in key code space over here like this will produce a Boolean which will be equal to true if the space key is held down. So I mean, key is pressed. So when I press the space, this will be equal to true. So after I do this, I also want to check if my character is on the ground. So I have another function over here called grounded, or let's put is grounded. And I will create another function over here that will give me a Boolean is grounded. And this will basically produce your raycasting. And basically this will raycast your rays and see whether your player is touching the ground. So to divert a little, you can see in the slideshow, right? Can I? Yes, no. Can see? Okay, can. Okay. So what does raycasting look like? So the red square in the middle of the screen will be represent the player. And these green rays are basically what's happening behind the scenes. So it will basically raycast downwards and see, and if it hits anything, it will send a signal to us. That's the essence of raycasting. and what is. So let's go back to scripting. Right now, what you're gonna have to basically tell the script where I want these raycasts to be originate from. So if back to the slide, if you can see, right, these raycasts will shoot from here to here. Because if you think about it, if a platform was like from the halfway mark until the right, this ray will trigger and your character will still be grounded and able to jump. Likewise, if you go from left onwards, this one will trigger and then the player will be able to jump as well. So back to here, I want to specify, most of you probably haven't seen this before, but I'm just gonna try my best to explain it. Okay, what bounds are is basically a area of which your collider is bounded around. So right now, our collider, if you remember, is a box collider 2D, which means it's a square or rectangle, because squares are rectangles. And it gets the bounds of our rectangular box collider. Yeah. Next, you want to generate a raycast. So I have a variable called hit left. So this will be the left raycast and of type raycast hit 2D. And the function you're going to use, or the method you're going to use, is physics2d.raycast. So as you can see, we're going to use this, right? If I can find the, I think I passed it just now. Yeah, so we're going to use this overload, method overload. So what you need is the first is a origin of where your raycast is. So you're going to have a new vector2. And what you want to do is, if you go back to our picture, you want where the x-axis is a minimum and the y is a minimum. So basically this point over here. So you're going to put bounds dot min x dot x and bounds dot min dot y. So this will basically create the origin of your raycast to be the bottom left of the box. Next, you're going to want a direction of where the raycast is shooting towards. So obviously it will be downwards. Luckily for us, Unity has their very own way to so they don't have to write new vector to 0, -1. So over here, as you can see. So vector dot down. You want to have next, you're going to have the float. So this is the distance of the raycast. I find that using a raycast of 0.1 f is usually the best for me. So that's what I put here, which also specifies the length of this basically. So the length of this is going to be 0.1 units in Unity. Yeah. And the last part, if just now if you could see, is called layer mask. And I'll explain to that. Basically, I have a platform mask. Okay, let's just create a new variable up here. And you're gonna write public. Let's put it below walk speed. Public layer mask, I think, and then let's call it platform mask. So this will be a layer. So in Unity, we have different layers for different things. Some layer is UI, some layer can be the water layer. In this case, you want to have a layer for to specify which game objects are platforms. So over here, you have your first raycast. Now let's make the second raycast on the right. So it's going to be the same thing. Okay. Now for the origin of this raycast, you want to make it on the bottom right of your player character. So what you're going to want to do is get the bounds dot max of x and the bounds dot min of y. This will mean that the max of x is basically on the right side of the character, and the min of y is at the bottom of the character, which means it's on the bottom right of the character. Similarly, it's vector2.down. You want your raycast to be this long, and your layer mask will be your platform mask. And since you know that this will return a Boolean, you can just return hit left or. So this is the short circuit OR. What a short circuit OR basically is that it will try and run hit left first. If hit left equal to true, then hit right won't even run. But if hit left equal to false, hit right will then run and see whether the whole thing is true. Yeah. So this is short circuit OR. You can also use one, but it's less optimal. It's like less optimized than the short circuit version. So we have a function that checks whether the player is grounded right now. So let's go back to Unity and see what it looks like. Okay. So if you go into your player, when you scroll down, you can see that there's this platform mask. And if you click platform mask, you should get all these layers, and all these layers correspond to the layer over here. So you're gonna want to go to layer, add layer. And what I did was I added my own platforms layer here. So this should be empty for you. So you can just type in platforms or whatever name you want. You can call it obstacles or walls or something. Yeah. And then when you go back, you should change this to your new platforms layer. Your platform should also be changed to the platforms layer. So now your player will raycast downwards. And then since this is a platform, it's under the layer platform, you should return true on the raycast. So let's just debug.log hi. And then you go back to Unity and let's see, and if you play, let's see how it looks like. So I can see, okay, let me minimize screen. Yeah, so if I press space, it will show hi, hi, hi. But right now it doesn't jump because we haven't coded any physics into it. So let me go back to this page and then I'll hang around for a while so that everyone can see the code and copy the code down. Yeah, and if you're done, please press a tick on Zoom so I know that you're done. And again, if you have any questions, do put it in the chat. Sorry, what plugin do you use? Okay, so for VS Code, these are the extensions that I have, but you just need 3 of them, which are the C#. So C# 1 should be the default. Debugger for Unity, as well as Unity tools. I am just gonna put it in the chat. So you need C#, debugger for Unity and Unity tools. Yep, the other two here, I use it for my own CS mod, so you don't need this at all. Yeah, so it's mostly these 3. 1, 2, and 3. Yeah. No problem. All right. So if is anyone like not done, like vehemently does not want me to continue, please say so in the chat. I'll give like 10 seconds.
Kenneth, is your platform mask on both the square and the ground or just the ground?
Just the ground. So as in the layer, is it?
Layer platform, yes.
Yeah, layer platforms is just on the platform. Because you don't want a case where if your player is also the layer of platforms, then the raycast might trigger and basically you have infinite jumps. Yeah. So let me go back to the script. Yeah.
I actually coded out what you typed, but then once I press space, I don't get the debug.log. Hi. So
how is it?
You try whether you can get it.
Do you? Yeah. I tried this now. Okay, let me. Did you put it in update? The function in update.
Okay, okay, yeah.
Because you're calling every frame, yeah. So you basically check every frame whether you press space and it is grounded. Yep. Okay, then I guess I shall continue. So yay, we have our first our jump kind of works now. All we have to do is make the character jump. So the first thing you're gonna want to do is basically the same over here. So I want to RB control the velocity. Nope, sorry. And I want to change it to new vector 2. And what I want is the rigid body's velocity.x component. And what I want to do is I want to increase the velocity on the y-axis. So what I can do is okay, let me just copper. Okay, so you can also do jump speed, which will be a vector. So you go up here and you add in a public float jump speed. And over here, ta-da, you will, okay, it compiles. So basically what you have is I want to take the x velocity of my player, which is not affected by my spacebar, and add a jump speed to it. So this is the new vector where your character will fly towards. So let's go back to Unity. And if you go to player, and let's do 3. I have no idea how it will look like, but if you press play, yeah, as you can see, as you press spacebar, the character jumps a bit. And if I spam spacebar, I don't know if you can hear me spamming the spacebar, but I'm not jumping off the map. So if you want to make it higher, you can just multiply this by twice the height, save it, and press play. And yay, you jump higher. Yeah, and you can move the guy left and right. So it creates like this floaty guy kind of movement. If you want to move faster, then all you have to do is increase the walk speed. You want to jump up higher, you increase the jump speed. Yeah, so going back to this, and here's the code. So for you to copy. Yeah, I'll wait around 1 minute and then we will continue. Yeah, if you have any questions, please put in the chat. So. I can get a copy. Sure. Let me, okay, wait, let me just copy this part. Why does it paste this across Zoom? Wait, let me try again. Because Zoom doesn't allow me to copy so much. Okay. I shall post it on the Unity platformer chat on Discord. It looks so ugly, but yeah, I'll format it later. Just go on Discord and it's in Unity platformer. Yeah. Yeah. And while waiting, I'm gonna just create a let's see whether I can do this. Hmm. Yep. If you have any problems with your player character, please also put it in the chat so we can kindly assist you. Yeah. Okay. Okay, I'm gonna assume that everyone is A-okay. No, nothing. So yeah, just put a tick if you're okay in the reactions, and I will move on in like 20 seconds. Yeah. Tick, tick, tick. Okay, cool. Just keep ticking. Okay, I shall move on. Okay, so now you have a complete and functional player character, which works, right? So let me think. Okay, so right now, what I'm gonna do is I'm gonna take a break from coding and discuss a bit more of the intermediate side. So some of you are probably intermediate Unity devs, I would say, and you already seen some tutorials on YouTube. You just search like how to make a character jump, how to basically make it walk, and maybe you learn a thing or two just now using raycast. So now we're moving on to the intermediate section, and this section is to basically spruce up your platform of physics. This section is mostly physics, so please don't be discouraged if you don't understand it, especially if you haven't taken like H2 physics or you taken secondary school physics and you forgot or something. And the slides will be open to all after the session. I'll be posting a link onto the Discord of Unity Platformer. So please don't bother screenshotting because it's all going to be online. Yeah. Okay. So let's look at designing a platformer, right? So there are a few problems in terms of design when you design your own platformer. So you could say to your game designer, okay, please design me a stage, And the designer replied, okay, the easy clap. How high does the character jump? And then you as the programmer was like, as you calculated just now, you have a jump speed variable. So you reply, oh, 1.5 units per second. And the designer just looks at you and goes, what does that even mean? What do you mean 1.5 units per second? And this could cause a lot of confusion, which brings me to the next point. Programmers should be nice to everyone. So in my 2 years of working in game dev with art teams and music teams and game designers, programmers have the hardest job because we have to be nice to everyone and basically code everything in the game and make sure it works. So you're gonna want to have the best experience for your designers as well as music teams so that they are interested in working on your project. So you're gonna have to think, how do you want your characters to feel? So on the screen right now, there are two platforming heavy games. The one on the left is Hollow Knight, and the one on the right, Celeste. It's okay if you haven't played any of these games. Maybe after a thought, you might want to play some of these games. I recommend Hollow Knight. Celeste is also very cheap right now. So yeah, you might want to look at how they design the movement mechanics in these games, and maybe you want your character to feel very airy and floaty. So you're gonna want like a really, really slow jump and a graceful fall, or you want it to have like really, really tight controls, like a platformer like Celeste. So you're gonna want very, very, very minimal air resistance, just like zooming here and there around the map. And you need to ask yourself, what are some of the things I have to give my designer in order to plan the stage? So you're gonna have to ask, how fast does my character want to move horizontally as well as vertically? And how fast does the character fall in the game? So how do we solve this problem? And well, I gave you away the answer just now, but maybe you could write in the chat if you think you know what the answer is. I'll give you like 10 seconds. You can write in the chat or unmute yourself to make it more interactive. Kinematics. Any more? Don't worry if you don't know, you can make wild guesses. Okay. 10 seconds-ish. Okay, yeah, so Junior, you're right. Welcome to physics and the kinematic equations. So, so what these kinematic equations do is basically give us a little, all these equations are basically based off of real world stuff. And if you wanna actually read up on this, you can read like random physics textbooks online. I think secondary 4 they cover how to derive all these equations. So what do all these symbols mean? So if you haven't taken physics, S is the displacement or the distance traveled from the starting point. This is measured in units. U is your initial velocity. And the difference between velocity and speed is that velocity has a magnitude as well as a direction, whereas speed only has magnitude. What this means is that the velocity is targeted towards a certain point, whereas speed is just a measure of how fast you are. So V will be your final velocity. A is acceleration, and T will be the time taken throughout the entire movement. So knowing these 5 equations, which are on the screen now, how fast does your character move horizontally? Let's say I was a designer and say, I want you to move 10 units per 2 seconds. So you search the list and then you find this equation, S equal to half U plus V T. So if you substitute S equal 10, U equal to 0 and T equal to, you can find what the final velocity of your character will be. U equals 0 is because the initial velocity will be 0 units per second. And naturally, you move 10 units per 2 seconds. So S will be 2 and S will be 10 and T will be 2. And substituting all this, you will find that V will equal to 10 units per second. So you realize that instead of you telling or like you coding in 10 units per second, you can actually write down how many units you want to move and what's the time you want to move this amount of units. But more on that later into the coding section. So how fast does your character move vertically now? So let's say I want him to move 5 units per 0.5 seconds vertically. So the same formula is on the board right now. Can I just write down in chat, do you think you can use the same formula and why or why not? I will give around 30 seconds to a minute for people to reply. Just say yes or no. If you don't want to write why or why not, it's fine. But you at least just say yes or no, yeah, in the chat. Just keep the answers coming. Okay. No, because this is acceleration equals to 0, downwards acceleration. Anything else? Yes or no? Don't be shy, guys. It's an interactive session. You can also put in the chat if you have close to no idea what's happening, so I can try and answer those questions before anything else. Yeah. So all right. So no, because this is acceleration equals 0, downwards acceleration. So Kai Kiet, I'm gonna assume that you said no also. So let's take a look. You have your kinematic equations on board, and the answer is actually can is can, but how would it look like? So going back to Unity, I hope you can see my screen now. Let's go to the movement demo. Okay. Let's just go to the. So actually, what we just coded is an example of using this equation. So what we have is a constant upward speed and a constant downward speed. So if you count 1, 1, 1, 1, it's the same value going up as well as going down. So going back to the PowerPoint. Yeah, so can is can. And how it look like? Exactly the same as we have coded it just now with nothing else, no other platform of physics in there. So what do we need to find out? Gravity, right? If you because in real life, if you try to jump and you realize that you fall faster than you take to jump. You can experiment it with it later if you don't believe me, but most of the time, normal physics in the real world works like that. So back to the math. Let's find this equation let's use equations to find gravity. Right now, let's say I want him to move 5 units per 0.5 seconds vertically. So using this equation, S equal to ut plus half at squared, you want to move 5 units, so S equal 5. Your initial velocity is 0 because you're starting at rest. The time taken is 0.5, and the A in this case is gravity. So in this case, G or A is 40 units per second squared. Yeah. Don't need to screenshot, this will be available after the talk. So let's move on. But wait, there's more. Is this correct? So is 40 units per second squared correct for gravity? So maybe you can put it in the chat also. I'll give like a few seconds. Is it correct? Yes or no? You don't have to put Y or like intuition. You can just say yes or no in chat. No. Okay. No. No. Anyone else? Yes or no? Okay. So the correct answer is no, because gravity is a downward force, and we're assuming positive force to be upwards. So in this case, the correct answer will be minus 40 units per second squared. So I know I talked a lot about the theory. So this is what it looks like in code. It's essentially the same as what I calculated all the times before. So in this case, gravity will be equal to -2 of jump height. So jump height is just the amount you want to jump. And math power jump time 2 just means jump time squared because it's a power function. And Unity doesn't have like, I don't think it has inbuilt power function. So you have to use the mathf library. And for gravity, you just want to assign physics2d.gravity to be 0 gravity. And remember that to put a negative sign because you don't want the gravity to reverse upwards. Yeah. So I'll just move on first because this will be available later. So jump speed. I want him to move the same 5 units per 0.5 seconds. So you know the drill. Let's use another formula. In this case, is this formula to calculate the final velocity. So final velocity equals to u plus at. We know since you start at rest, u equals 0. A equals 40 minus 40 because it's gravity. And t equals 0.5 seconds. So v equals to minus 20 units per second squared. But remember that you have to flip this because basically if you jump, you want to have a positive force upwards. But if you don't flip it, it will just still be negative. So you're basically sinking low into the ground, which what you don't want to happen. So just remember to flip it. And this is what it looks like in code. Very simple, jump speed equal to minus gravity times jump time. Yep. And let's compare the difference. Okay, so this is my most exciting part. So welcome to the live demonstration. Let's go to, okay, it's my start of workshop. Okay, and next one is a play. Okay, so this is our original guy, you know, up, down, up, down. He moves left and right, and it's basically very feels very floaty, you know, doesn't really feel like any real world stuff. So let's move to the one that I just demonstrated. So if I press spacebar, you can see that it jumps up height and it lands down even heavier. So it feels like your character has some sort of weight. Plus, if I want to design a stage, I can also, the designers can go, okay, so the maximum jump height I can do is 10 units. So the maximum platform I can place from between different sections is 10 units. So it makes it much easier for any designer to design the game. Yeah. So yeah, if you do want to look more on this topic and also see the script of whatever I just showed, there is a link to the script. This is my own GitHub for my script library, selfless plug, but it's over there. And there's also a link to the video that explains much better than what I just did. It talks about a lot of different sorts of math if you're interested in it. So do watch the video. It's very informative if you're interested. Yeah. And okay, let's move on to the last part of the workshop, which is the advanced section. So hello to the few of you in the chat that probably know all this already and who took physics. So now we'll be discussing two concepts that some platformers use to have a better player experience. So we will not be covering scripting, but if you are interested, you should probably go find out by yourself. And there are some links later on in the talk. So these are just like, airy-fairy concepts that I'm just going to go through now. So the first thing is acceleration and deceleration curves. So let's take, for example, Super Meat Boy, one of the many platformers out there, one of the better ones. So right now you have, Super Meat Boy has a very, very slow ramp up time. So the character will reach max speed over a longer period of time, but will come to a stop relatively quick. This is because you don't want a case where if let's say they created it such that acceleration and deceleration curves are exactly the same. You're gonna have a character that slowly accelerates and we're at max speed, and let's say there's a spike in the way. If you want to stop and you let go of the button and he just slides into the spike and dies, and you as a player you feel like, oh, this is super unfair, the character doesn't, this game is basically unplayable. But if you take a look at this, if with the slow ramp up in speed, you can actually give the character a few of it actually has weight, because most characters don't go top speed immediately and just run like our character just now in our workshop. But instead, it slowly ramps up until it hits top speed and it maintains at top speed. And when you let go, it's a fast ramp down. Yeah. So this is just an example of how it looks like. So as you can see, when you start, it starts ramping up speed, and then at max speed, you can just see how fast it goes. Yeah. So this is one of the things you can look into. Next, let's talk about someone. So this on the screen is my good friend, Willy Coyote. He is used in a lot of good games in terms of platforms to help us with physics. So if you see the GIF on the screen right now, you can see that when he runs out the cliff and the roadrunners just stares at him as he plummets to his pseudo-death, because cartoon characters are essentially immortal. You can see that he hangs in the air for a bit before jumping down. And this form of animation, or there has actually been a platformer physics thing named after him, which is called Coyote Jump and Jump Buffering. So this allows the player to still jump, although they press the down key early or late. What this means is that in the picture over here, the dotted squares is where the player press the jump button. So on the left, you see that the yes, Coyote, yep. So on the left, you can see that the guy actually press the button when it's not on the platform at all, but the player still jumps. And on the right, you can see that the player actually hasn't touched the ground yet, but is still able to jump. So if you want to learn more, there's a link to the video in the slides. You can click on it and you can watch the video and see whether you want to implement it in your own platformer. And with that, that is the end of the workshop on platforming for today. Just covering movement basics. And next week, we'll be talking about animation and how to implement animation in your games. So I guess as homework, you can create a stage, just a simple platforming stage to jump around. Maybe come up with your own platformer idea as well. And most importantly, you can we'll probably be posting some generic sprites for you to use next week for the workshop. But if you want to go the extra mile and make your game stand out, please do draw your own sprites. You can use normal pixel art software like Sprite, anywhere. You just search online. Yeah, maybe we'll post some links too on the Unity platformer. But yeah, next week will be on animation, and yeah, please come also. Yeah. So thank you for listening. Now we'll be moving on to the Q&A part, and I hope you learned something new no matter what your level is. In case you knew all this already, which I applaud for that, over here will be a game that I played it's also a platformer, but it made me suffer a lot. It's $5, and yeah, it's very painful. But yeah, you can go check it out if you're interested. So thank you for watching, and I shall stop the recording now.